Hello friends, welcome to our first week of kind of diving into some physics-y concepts. So this week is a math review actually, because physics is really applied math. So we want to make sure that we all start out at the same comfortability level with using math for physics problems. Okay, so with that, I'm going to explain how this week's assignment is going to work. So what we will be going over is sig figs, SI prefixes, scientific notation, unit conversions, dimensional analysis, basic geometry, and scalars and vectors. So this first video here is going to cover topics A through C. The next video, video 2, covers D through E. Then F is video 3 and G is video 4. So that additionally, I want to point out how this packet is laid out. So, for example, part A, sig figs. The questions in this packet are actually the homework questions that are on the Google form, okay? The questions that I'm going to go over, like through this guided video, are not these questions, okay? However, I do give you a spare page at the back of each section for your own notes. So this is where I would recommend you take notes on what I am going over right now in this guided lecture. So this is section A on significant figures. Before we get kind of into talking about these examples and like the significant figures in these two examples, I want to talk about why we care about sig figs in the first place, okay? So for that, actually, let's scoot to my kitchen. Let's say you go into your kitchen and you want to make some chocolate chip cookies. So you pull out your recipe. Let's say that it calls for a half cup of sugar. And you have two instruments to measure that out. You have a choice of two. You have a 1 cup measuring cup. And you also have a measuring cup that has different amounts within it labeled out. So, you know, a 1/3 cup, a 1/2 cup, 3/4 cup. Think about these two instruments in terms of how much you trust you could get that 1/2 cup measurement. This question of which measuring device, which instrument to use to best get at that 1/2 cup of sugar is really a question about sig figs. And what sig figs really tell you are how much do you trust this measurement? So when we think about science, when we think about physics and tackling these types of problems, that's where sig figs come into play. How much do we trust our data? Hopefully those food examples help show you how important sig figs are in terms of trusting those values. Translating that into science is pretty important because, you know, think about it. If you have a medication dosage, you know, don't you want that to be, you know, you want to be pretty confident in that, right? So depending upon the instrument we use, we can get different kind of confidences. What does that mean in terms of our physics class though? Like how confident, how many sig figs do I want you to use, you know, before you're worried I'm gonna take off points? The answer is be reasonable, okay? I care more about being able to follow your train of thought than, oh my gosh, you got 2 digits instead of 3. I would much rather be sure that you understand what's going on than necessarily, you know, oh, if you're a digit or two off, okay? Let me show you an example of what I mean here. And I also want to give you a hint for physics problems. For the most part, the numbers that a physics problem give you, such as this one says 735 kilograms. So, haha, 3 digits, right? For the most part, whatever number of digits they give you, you're going to give back. So when I actually solve through this problem, in which we'll get to this later, you don't need to understand all the physics of what's going on. But basically, when we calculate the potential energy, we find that the answer, before I start rounding it off for sig figs, is approximately this many joules of energy. And if you're about to turn in a homework or a quiz and you're like, oh my gosh, like how many sig figs should I give? Technically, give 3. That's what the problem gives you. But I'll be honest, if you put this number down, I'm fine with it. If you put that number down, I'm fine with it. I care much more about you showing your work and your thought process than if you rounded a digit off, okay? Okay, let me show you another example of what I mean by rounding off, okay? And the number of sig figs. Okay, so my 75 kilogram dog is asleep on the floor. Calculate his weight. Again, we'll get to these actual the equations that get you the answer later. What I want you to see is that right here, we have 75, so that's, can't spell, two digits, right? So when I actually solve this problem, I get that my dog's weight is, before I round it off, is approximately 735 newtons. If you leave that answer for me, it's my dog howling. 1 second. She's the great guardian of the house. So if you leave it as 735, that's fine by me. I can see that you got to the correct answer. Technically though, the problem gives 2 sig figs, so you would actually round this to 740 newtons. If you gave me 740, if you gave me 735, cool. Again, what I care more about is your work. The more work you can show me, the better, because I can follow your thought process more easily. Okay, that's really all I want to say about sig figs, okay? They have importance in real life, in instrumentation, in terms of calculations, y'all. Show me your work. Cool. We are now gonna dive into section B, the SI prefixes. SI prefixes, you tack onto a unit to describe it, right? So let's say our unit is the gram, and a prefix we might add is kilo, in which we'll go over that in a second, but it's really a descriptor, right? A kilogram, a milligram. These prefixes are descriptors that go in front of your base unit. And why do we really care about using these units at all? Like, why are units important? Well, first, I'm just going to tell you, units are very important. So imagine that you're a scientist, right? And, you're trying to publish your stuff and, it's revolutionary. Well, we like to have common units in science so that we can easily compare and contrast values. For example, let's look at someone's height. Person's height. Here in the US, we use some weird units that nowhere else really uses anymore. So we describe our height in inches and feet, right? So I am 5'7" tall. Pretty much everywhere else in the world uses the base unit of the meter and then describes themselves with the prefix centi, so they give their height in centimeters. Now, I don't know about you, but I cannot easily in my head compare and contrast heights that have different units. So where do the prefixes come in here? Here's the deal with the prefixes. A prefix is added to the front of a base unit. And I know y'all have seen these before. So, for example, we have milligram. I know you've heard of those before. I know you've heard of centimeters. I am going to show you a chart of SI, so metric prefixes that that you may encounter, and that some of them that we definitely will encounter. This is in your review packet. If this is difficult to read from my document camera, please zoom in, okay, on your review packet. I am going to be upfront here, okay? You do not need to know all of these. You do not need to know all of these. I don't know all of these. However, there are a couple of common ones that are going to come up continually that you should know. That is in one of your homework problems. It includes, let me put this over here. There we go. It includes kilo, deci, centi, milli, micro, boop, 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 and nano. See how we have the prefix kilo, abbreviation K, and its value, which makes a little more sense when we're going to look at the scientific notation. So again, let's, for example, milli, M, 10 to the minus 3. Micro, mu, so this symbol right here is the Greek symbol for mu, 10 to the minus 6, okay? These are the ones you should be familiar with because these are what you're going to see in the physics class, okay? So these prefixes are nice. They help simplify some of our understandings and comparison of the values, but it can be kind of hard to visualize what they mean. So certain prefixes basically say, hey, the value you have has this amount of magnitude, this number of decimal places, over. And maybe it's a big one, big value, maybe it's a small value. So these prefixes help orient us to that. So for example, if we look up here, one of the ones you don't have to know, you don't have to memorize, is exa, capital letter E. It means that your number, your measurement, your calculation has this big of a magnitude, 10 to the 18. If we look at kilo, K, it has a magnitude of 1,000. And in scientific notation, that's 10 to the 3. Conversely, we also have prefixes that represent super teeny numbers. So if we look at nano, N, that is 10 to the minus 9. So that's what this magnitude looks like, yeah? So we use these prefixes so that we don't always have to write out all of these decimal places and all these zeros, okay? It helps us, again, do a comparison check. All right. We are now on to the last subject of this video, which is scientific notation. Yay! Okay. Scientific notation, the reason we use it is it lets us compare the bigness or smallness of values more easily. Kind of like the prefixes do, right? Okay, so let me give you these three numbers. 10, 10 times 10 to the fourth, and then let's have 10 times 10 to the 100. In your head, your brain is already doing comparisons on these values because, oh, you know that this positive 4 really means 2, 3, 4. Move the decimal over 4. So this is this big of a number. And you know that for 10 times 10 to the 100, you're moving that decimal place, there we go, to the right 100 times. Or you also know that if you have 10 times 10 to the minus 100, that you're moving that decimal point, pointing the right direction, to the, wait, no, there we go, the right direction. You're moving that decimal place 100 to the left, so really tiny. Scientific notation helps us write things so that we can compare and contrast very easily. But more importantly, I think, it makes it so that I don't have to write out 100 past the decimal place. That way, it's much simpler and much easier for us to write. Okay, some basics of scientific notation in case you forgot, which is fine. That's why we're reviewing. So again, let's say I have 1.23 times 10 to the second. If you have a positive number in this exponent, you're going to move the decimal to the right. So it's supposed to be an arrow. 2 to the right. So you end up with 123. If you have an exponent that's in the negatives, you're going to move that decimal place 2 to the left. So you end up with 0.0123. Yeah. In terms of significant figures, generally the number of digits you use corresponds to the number of significant figures. But again, my concern is not super about the sig figs, okay? Okay. Additionally, in case you forgot the terms, so scientific notation means to condense it into this form, and then expanded form is what we did here. We went from scientific notation to literally it's expanded, like write it all the way out form. I do want to make a specific note about the Google form answers. Google form. Okay, Google Forms is not fancy enough to let me have exponents in my answers. So the way you're going to see me write these answers in the choice options on your Google Form homework submission is like this. I'm going to use this 1.23 example. 1.23 times 10 caret sign. So this literally translates to the, and then I'll have 2 here. So this is 10 to the second power, okay? So you're going to see this little caret. That just means exponent sign, okay? Google Forms would not let me be any fancier than that. Okay. Woo, there we go. So this concludes the first video in the math review. So we covered why do we care about sig figs, how do we use prefixes, and why do we care about scientific notation. So here is, I think, a really good time to stop, pause, and go work on the homework for this section, yeah? And as always, if you have questions, feel free, please, please, please reach out.